Hey guys, we're back with notes for 3.5 that's going to be graphing inequalities. So we're going to be taking the same kind of equations that you saw in 3.3 with the y equals mx plus b, and the kind of equations that you saw in 3.4, which were the ones in standard form, and we're going to be applying that with inequalities now. So instead of just looking at graphing the line, now we have two additional things that we need to take care of. We need to worry about our line type, and we need to worry about what kind of shading we have. So what I'm going to ask you to do is go ahead and pause the video, and I'm going to zoom out. I want you to write down everything you see. All right, so now that you have that all written down, let's go ahead and get started. So the symbols that you're going to see today are either y is less than or equal to, y is greater than or equal to. Now, we do know that there are a few equations where we start with x. Those are the undefined examples. We're going to worry about them also. But for the basis of this topic, we're going to worry about the y. Okay? So whenever you see a less than or a greater than, let me go ahead and use the highlighter. When we see a less than or a greater than, and they do not have the or equal to under them, that is going to be when we use the dash lines. Okay? So it has nothing to do with where the line is located. All it means is that once you graph the dots, like your rise and your run, when you go ahead and you connect those dots, if there is not an or equal to underneath it, you're going to leave that as a dashed line. Not a dotted line, but a dashed line. Okay? Whenever you take that same information, but now it has an or equal to under it, that is when we're going to make a complete line. Basically, when we use an equal sign, we use a complete line. Same idea. If you see a less than or equal to, greater or equal to, we're going to put a full, complete, straight, solid line. Okay? That's going to be these problems. Okay? All right. Once we get our line drawn, that's when we need to make our second decision. Our second decision is, well, do I want to be higher than the line or underneath the line, above or below? That really comes down to the y-axis. So let me go ahead and highlight the y-axis for us on a couple of these. All right, so I've highlighted the y-axis. If I say I want to highlight all of the y's that are less than that line, well, let's zoom in. It looks like that line is probably crossing right about 2. So if I want all the y's that are less than 2, that would be all the ones that are lower than it. So when I shade this line, a less than would mean that I shade below the line. Below, less than. Okay? So it doesn't matter which way my graph is moving, I still would shade below that line. Make sure you shade the entire thing. So I know that some of you were doing that with a pencil, but if I was filling it in with a pencil, it would still look like this. Okay? I want to make sure that I'm using the whole space. What I won't take is this. Okay? Needs to look like you're filling up the space. So again, less than would be below. Doesn't matter which way the line is going. Okay? So a less than or equal to doesn't shade differently. I'm still below the graph. The only difference is my line changed. So my line type changed. My graphing would be the same if they're both less thans. Okay? Now, greater than and greater than or equal to, I want the y's that are greater than the line. So if my y is crossing at 1, I want all the y's that are greater than 1. That means I'm going to shade all of this. So a greater than means that I'm going to want to be above the line. Doesn't matter if it's a solid or dashed line, I just want to be above it. No matter which way it's facing, I want to be above it. Okay? So that's the basis of what the sign is doing. I'll erase the yellow. That way you don't have that anymore. Okay? So the only time that this gets a little bit tricky is when we change it and we start talking about x's. Okay? Because remember, an x equals is a vertical. That's an undefined line. So on this situation, we're saying the x is less than or the x is greater than. So if I'm looking at my x-axis now and I say I want the x's to be less than where they're crossing, which is 2. If I want the x's to be less than 2, that's these numbers. So a less than would be all of the x's left of my graph. Doesn't matter if it's less than or equal to, I'm still on the left side of my graph. So where would a greater than be? Well, a greater than would be on the right side. I would be shading all of the x's that are greater than where my line crosses. Okay, so I'll give you a second. Pause this video, make sure you have all your shading in the right place, and then I'll meet you on the next page. All right, so as we're going through these problems, the M and B situation is still going to be the exact same. The only thing that's going to change is when I connect the dots, I'm going to consider what kind of line I have. And then when I shade, I need to worry about is it above or below, okay? So let's go ahead and get started with problem 1. Problem 1, my slope is the 3. We make it 3 over 1. Remember, that's rise 3, run 1. I'm going to begin at -2 on the y-axis. So my first dot is at -2. I'm going to rise 3, run 1. I know I'm going quickly, but remember, you can pause this, okay? I'm going to start by getting my dots done on problems 1, 2, and 3, just to refresh your mx plus b, okay? All right, so on problem 2, my slope is -2/3. Remember, that's negative, so it's down and to the right. He is going to begin at a +4. So my first dot's on +4 on the y-axis. I'm moving down 2 and right 3 spaces, and I repeat that all the way across my graph. Again, that's down 2, right 1, 2, 3. Okay. Problem number 3, my slope is 1/4. It's positive, so we're going to rise up, run to the right, but we do begin at a -3. So my first dot goes on -3. I'm rising up 1, running 4. I can do that in both directions. Remember that means I'm going up 1 and then to the right. 1, 2, 3, 4. Okay? All right, once I have all my dots going, now I can go back, now I can go back and consider what kind of lines I have. Okay? So the line comes down to the symbol. Okay? So since that first problem has an or equal to, I'm going to say that that's a solid line. Why? Because it has the equal to. So when I connect my line, it's going to be a complete solid one. Problem 2 has the same thing. He's going to be solid also. Why? Because it has the equal to on it. That little line underneath in here, that is why I'm using a solid. Okay? Problem 3 doesn't have that little or equal to, so he's going to be a dashed line. Okay? So on this one, I'm going to say it's not equal to. So 2 is going to be one solid line. Number 3, though, watch what I do. I don't make it solid. I put the dashes through. I put the arrows on the end just like I know, but I don't draw one complete line. Okay? All right, for the last part, we're going to want to know where we shade. So on problem 1, I have a greater than. That's this way. Because it's a greater, I want to shade above. So with my color, I'm going to shade everything that's higher than where my graph line is. Okay, I'm going to fill that in. Problem 2 has a less than. Even though it says less than or equal to, it's still less. So a less than would go below. I'm going lower than the graph. So underneath my graph would be all of these values. Problem 3 has a less than also. Again, I'm talking about this symbol up here. It's a less than. So a less than means that I'm going to shade below. This one's really easy because the graph's pretty straight across. We're going to shade everything below that line, okay? That's the gist of it. Now, as we start getting a little steeper with lines, it starts getting a little bit tricky. So I want to do 1 or 2 of these, okay? Let's skip problem number 4. But on problem 5, I do want you to see this one, okay? So remember, when we have a y equals, that means our slope is 0. There's no x's. You can put that reminder if you want to. There's no x's. So that means my b is whatever number I see. My b is at 5 on that first problem. My b is at -1 on the other guy, okay? So from there, I need to decide what line type I have. Number 5 has an equal to. So that means he's going to be solid. I'm including that line. So solid, straight across. Problem 6 does not have a no. Ooh, I said solid. Haha. Solid. Number 6 does not have an equal to. So he's going to be dashed. Okay, so I go across. I'm still drawing my same direction. I just make a dashed line instead. All right, after that, I'm going to consider my symbol. Problem 5 is a less than or equal to. That means he's below. Problem 6 is a greater. That means he's above. So when I shade on number 5, I need to shade everything lower than the graph. Number 6, everything above the graph, so everything above that line. Again, remember, if you miss something or if you need to listen to it again, this page is filled out. You can pause anything you need. Let's go to the next page. Okay. All right, as we look at number 7, this is where the x's come into play. So remember, the x equations are the ones that are undefined. Undefined means that we do not have a y-intercept. These are the problems where we're going to start on the x-axis. So for problem 7, I'm going to start at -2 on the x-axis. It's going to be a vertical undefined line. I'm not going to draw it yet because I don't know what kind of line it is yet. Okay. Problem 8 is going to start at a +3 on the x-axis. Again, vertical line, but I don't know what kind yet. For number 7, because it has an equal to, we know that that's going to be a solid line. So I'm going to draw my solid undefined line. Number 3 is not equal to. So he's going to have a dash line. Still vertical, just going to be a dash. Okay. My shading is where it gets tricky because if I want x to be greater, I want to go where all the x's get bigger. On number 8, that's a less than, so I want to go where all of the x's get less. So on problem 7, we're going to shade on the right side. That's where I'm hitting all of these extra high x's. Number 8, I'm going to shade everything on the left because all of these x's are less than 3. Okay? Less than goes to the left, greater than goes to the right, but only if it's a vertical undefined line. Okay? All right, we're going to skip number 9. Last 2 that I want to do require a little extra work, so they do require us to do some rewriting. Can't get the slope and the b until it's in a y equals format. And the reason that we want to do this to rewrite format is because remember that if you divide by a negative, you have to flip the sign. So I can't use intercepts for this problem because I won't know if it ended up as a greater or a less than, okay? So let's practice our rewrite. We're going to go ahead and cancel off the 5x and move him to the other side. I'm going to switch my signs from the beginning. So I'm going to keep the 4y is less than, and I'm going to put the -5x first. Remember, our goal is to make it y equals mx plus b. So I'm going to put the x guy first. My 12 is still negative, so I put him at the end. I'm going to go through this problem and cancel off the 4. That means I'm dividing everybody by 4. Didn't divide by a negative, so we do not flip on this one. My equation is going to say y is less than -5/4. That doesn't simplify. And then -3. I got that by doing -12. Oops, let me change colors. -12 divided by 4 is how I got this 3. Okay? So that means my slope is -5/4. That's down 5, right 4. My b is -3. Let's go ahead and put those on our graph. Remember that if I can't go down 5 and right 4, I'm going to have to go backwards. So I'm going up 5 and left 4. Okay, your graph should be going downhill. I'm going to only put those 2 on there. Okay. All right, my line type, again, still right here, is a less than. It doesn't have an or equal to, so I'm going to make that guy a dashed line. Let's go ahead and connect those with a dash. And then because it's a less than, I do want to shade below. So I'm going to grab my highlighter, and we're going to go back and shade everything that was below that line. Okay? May seem like a lot of work, but we do need to show all of it. Okay, that's why there's only 2. Let's try number 11. We're going to do the same thing. Let's rewrite our equation by canceling off the 3x, moving it to the other side. I am going to put it in order. So negative 3y is less than negative 3x plus 6. I put the x's first because, again, we want mx plus b. I need to divide everybody by that negative 3 that I kept. And when I divide by a negative, that means I do need to flip it. Okay, so I'm going to say y is greater than negative 3 divided by another negative 3 is going to make a positive 1x. You can just say a positive x. Second part, 6 divided by negative 3 is a negative 2. So that means my slope is 1 over 1. My b is negative 2. Let's get that going. Do all my dots here. All right, from here it's time for us to consider, ooh, I almost missed that. Look at my signs. This one's a less than or equal to. I forgot the or equal to on both of those. So since it is an or equal to, I do need this one to be a solid line when I connect them. And since I flipped my sign, that means I now have a greater than. That is going to need to shade above. So I'm going to go ahead and get my highlighter, and we're going to shade everything that is above. Remember that if you are using a pencil to shade, which I assume you are, this does not count. Okay, we're not doing that. If you want to shade it and shade the whole thing like this, I'm fine. If you want to do this to show full use of your boards, that's fine. I think most of us will probably grab a highlighter and highlight through it once we know what we're doing. I wouldn't use a highlighter until you got the hang of it though, okay? All right, you should have enough information now to do 3.5 practice. Come see me if you have any questions. Otherwise, you are ready to roll.